Alright, we finally got the floor finished. It didn't come out too bad. Like I said, the floor is kind of uneven. You can see bubbles here and there. Like here and here. If I get really down to it, you can kind of see that it does a little bit of this. But, I mean, they're down there, they ain't going, and we're nice and straight. And the only real problem I had was uneven walls. So, as you can see, I don't know if we can get a good shot down this wall. You can see the wall bows that way, and I just cut them to fit. And the only part that I haven't finished yet was over here by the oil tank, because this track isn't perfectly straight. It's really crooked, so I gotta just cut those around the corner, and I'll probably stick those down with something like liquid nails or something. I just don't want them to pop up instead of trying to glue them all down, especially these little pieces in here. But besides that, floor's down. It just needs to be polished, which is obviously the last thing I'll do. Right now we're working on the electrical, and this is just kind of going to be a preliminary video just to show you some of the stuff that you're going to need to do this. Again, if you're not comfortable working with electricity of any kind, obviously hire an electrician, because it is dangerous. Also, abide by any local and national codes, which can get to be a little bit of a pain. I'll kind of show you that. And, you know, just be safe. And so this is our basic layout here. What I really wanted to do is I have a 8-foot 4-bulb T5HO fixture here. That was going to be put right here. It's still going to be put right here, but what I really wanted to do is have that switched. I have a 3-way switch up at the top of the stairs, and there's one in the back stairs over there that control this light and a light in the back. I wanted to keep that as is, have that switch the big 4-light fixture. This 2-light fixture I wanted to put off of a switch here and put it pretty much above where I'm standing, kind of in the middle of these pipes here. And this right here is going to be an outlet, and that's going to be an outlet. So basically this wall here is going to be one circuit, and then we're going to be running another circuit that's going to be dropped down the cement wall. The only problem that I ran into is the breaker that is actually controlling those 3-way switches, and this light is hooked into a lot of stuff. We're hooked into basically all these that I have down here. There's one here. There's actually one right there, and there's 2 on this wall that you can't see. That is also hooked into all of my lights in the old house, except for the kitchen over the dining room table. It's the only one that's not hooked into. It's hooked into both bedrooms, the main bathroom, and the hall lights. Luckily, the master bathroom and bedroom are all on separate circuits. So, granted that light there only draws 2 amps on 4 bulbs, I kind of want to keep as much off of that circuit as possible. So, I may have to, I kind of have to figure out the lighting, how it's going to be hooked up and controlled for the time being. But mostly we can get all of our rough in and all that stuff in, and then obviously I got to put the plasterboard up on here. And I know somebody had suggested in Owen, was it Owen? It's not Owens Coring, Georgia Pacific DuraShield with sheetrock, which instead of having paper backing, it's fiberglass. I priced that out, and even with my contracted discount, it's twice as much as regular green board is, and I can't justify the cost of it. So I am going to go with just the regular green board on there, which should be fine. As like I said, in the past week or so, we've gotten about 2 to 2.5 feet of snow, and today and yesterday it's been 50 degrees out, so it is melting, and it's melting hard and fast, and I haven't had a drop of water or moisture back yet. So my plan for electrical is I'm going to have an outlet right here, which is probably going to be where my grinding and polishing station is going to go. That is going to be a GFI, my first GFI. That GFI is going to be hooked into another box that's going to be mounted right there. That's going to have 2 outlets in it. Another box right there that's going to have one outlet in it. That's probably going to be for my drill press. And another box right here that's going to have two outlets in it. And that's going to be where my lathe sits, probably right on this wall here. So let's touch a little bit on electrical code and why it's a pain in the ass and why electricians charge so much. And some tools and equipment that you're going to need. This is the big bad book. This is the Bible for electricians. This is the National Electric Code. This is the 2011 version. There is a 2014 version which I have out in my van. This just happens to be on my shelf. Depending on the state that you're in, since it's early in the year, some states may or may not have ratified the 2014 version yet. Massachusetts has, because this book actually originates out of Massachusetts. This is pretty much where it's made. Now, there are a few problems with this book. This is basically minimum code. This doesn't tell you how to hook anything up, but this tells you what the minimum standards for safety. As wire gauges go, box fill, what you can and can't do is all in this book. Now, this is why electricians charge so much, is because they have to interpret the gibberish in here. And like I said, there are a few problems with this. You see here it says National Electric Code, and underneath says NFPA, National Fire Protection Agency. So you're like, oh, okay, it's you know, for safety and whatnot. But if you turn past table of contents here and you look at this here is basically all the contributing people that have something to do with writing and ratifying the code. The only problem with this, if you go and look at who some of these people are, they are all manufacturers and things like that. You'll see there are manufacturers, a lot of union reps and stuff like that. You'll see a few here and there of actual safety committees and stuff like that, but for the most part, I mean, you look at Representative Independent Electrical Contractors Incorporated, Representative Siemens, Representative Challenger Electrical, National Electrical Manufacturers Association, UL listing, United Laboratories listing, and stuff like that. So basically, the people that are selling you the stuff to use are the people that are saying that you have to use it. That's a big problem because there are some weird things in here that make no sense and that are just more expensive to use than something else. Case in point are arc fault breakers. Those of you that don't know what an arc fault breaker is it's a special breaker, kind of like a GFI, but basically if there was an arc out on any type of unit, it can sense that really, really fast, faster than a normal breaker, and it'll shut it down so you won't get that big poof of sparks. They only used to require those in industrial applications for obvious reasons, because you're working with 600 volts and stuff like that. But now they're required every livable space in a home. In Massachusetts, if a smoke detector enters a room, that smoke detector circuit has to be AFCI protected. So who is going to pull down who's going to pull down a fire alarm and stick a fork in it? There's no reason for it. Actually, it's bad to have that, because if anything happens, your breaker's going to trip. So if you have a fire, if that fire were to slightly ground out a line, even just a little bit, and you get voltage leakage, it's going to pop that breaker, and your smoke detectors aren't going to go off. So there are things like that that are just a little bit overboard. Now, say an arc fault breaker will cost you about $40, whereas a regular standard breaker of the same size will probably cost you $5 to $8. So I mean that's just a little ridiculous. Also, the other fun part with this book here is, as you can see, I have crossed out some things. Some things are highlighted here and there. Every state, and in some cases county, has addendums to this code, which override what is written in this book, that go above and beyond what is written here. This is minimal safety standard, but some, like I said, counties and states want something different. The other issue what you have here is enforcement of code. Now there is an addendum, seeing this is Mass Code pamphlet, there's an addendum for the Massachusetts inspection. That's off the top of my head, I can't remember what it is, but what you have here, by special permission, the authority having jurisdiction, that is the inspector, AHJ, which can also stand for something else, may waive specific requirements in this code or permit alternative methods where it is assured the equivalent of objectives can be achieved by establishing and maintaining effective safely. What does that mean? That basically means an inspector can override this book at any time and any point. Now, you can challenge the inspector's override if it's justified. So say you're in a house. Inspector walks in and says, I don't want any non-metallic cable in this house. I don't want any Romex. I want only armored cable. Well, you can put a grievance in and go through the process and have that overridden. But, like I said, in most cases, the inspector can override this at any point in time. Now, inspectors themselves are not infallible. They can screw up. Some of them are nice, some of them are assholes, and it all depends on state. Your locality and the person, and it even and it also depends on the person as for thoroughness. I mean, I've done jobs for work where we have changed services and we've pulled tons of wire. Inspector came in, took maybe 10 minutes, looked, yep, you're all set, out the door. I've had other jobs where I've seen electricians change literally 4 outlets, run one circuit, 4 outlets. The inspector went to every outlet, pulled it out, looked at it, put it in, tested the ground, tested everything with the little plug-in testers that pop the GFIs there. Tested every outlet and everything else. I mean, so it varies by locality and person. It's amazing. Now, like I said, you can see all these tabs and everything here. These are all the main code articles, and you have all kinds of stuff in here, coming from box fill to amperage ratings to everything else. And like I said, interpreting this and adhering to this is pretty much the crux of being an electrician. And I mean, you can see how thick that is, and it's not worded really well. I mean, it's not worded like a normal person would talk, so you kind of have to interpret what the hell they're saying, and a lot of times they'll bump you back and forth between code articles. So you try to find something, it says look here, and it says see article 210 whatever, see article whatever, and you have to keep bumping back and forth between articles. So it's pretty fun. Now, for our purposes here, what we need, be aware that if you have an existing circuit and you modify it, you have to bring the rest of the existing circuit up to code. Now, there are exceptions to this that are allowed in certain states. Some states, Massachusetts surprisingly, states that you can modify a circuit as long as it doesn't exasperate any existing electrical code violation. So in other words, if say a wire breaks, you can replace that wire without having to rip out walls and everything else and replace the entire circuit. Replacing an outlet, replacing what is already there, does not constitute changing anything in the circuit. You are just replacing an existing device, so that is a moot point. Now, we're starting from fresh, so we really don't need to worry about any of that stuff, but our circuit down here is going to be off of a 20 amp breaker, so we are going to need 12 gauge wire. Now, wire gauges are color coded now. Years ago, if you look at your house, you may have all white wire, maybe some black on service entrance cable and certain things, but generally now, I forget when they actually started doing it, they're color coded. So 14 gauge is white, 12 gauge is yellow, 10 gauge is orange. This happens to be 3-wire. This was what I used for the dryer. And if you see a gray wire, usually that is a UFB cable, which is an ultraviolet direct bury cable. And I'll kind of show you the difference between those in a bit. Actually, well, yeah, I'll show you right now. Now, if you look at the front here, you'll see this is regular piece of Romex. This is the UFB cable. You can zoom in a little bit here. You can see you have one wire here with the black jacket. Here's your ground, and here's your neutral with the white jacket. Now they're encased completely in a PVC coating. If you notice in the regular Romex, the PVC coating is just on the outside. Here's your black wire, here's your white wire, here's your neutral, and they're just encased in paper. So that's the difference between them. This cannot be used in a building as wiring, as regular wiring in place of this. It can, but it has to be 90 degrees Celsius rating, and the amperage rating of it can only be 60 degrees Celsius wire. So in other words, you're derating it because of this. But it can be used at its normal voltage if it's used in its correct manner, which is for underground wiring, usually to light poles and stuff like that. So now I'm going to show you some things that we're going to be using. Like I said, we're going to be putting in a GFI circuit all the way around. The boxes, let me show you the boxes that we're going to use, some differences between them. Here's a regular 4-inch box, shallow box. Here's a 4-inch deep box. And here's a 4 11/16 box. Now, I prefer the 4-inch deep box just because of the fact that you have the extra room to tuck all your wires in, especially if you're using GFIs. That is one of the biggest things I see when DIYers do wrong, is they overfill the boxes. There are box fill calculations for certain things. It has to do with the size of your wire, how many wires are entering your box, if they're terminating in your box or looping straight through, how many gang devices you have in there. It's very complicated. So usually, generally, if you can, just get the biggest box you can. But try to stay away from these 4 11/16 boxes. The reason why is because these require a special cover for them. And the special cover requires a switch plate for it. So in other words, these 4-inch boxes use covers like these that you mount the plugs, the outlets, or whatever device you're going to put in there to. And by the way, if it has 3 holes, you have to use all 3 holes. These 2 here are bolted through with a nut. You can't just use the center one anymore. Now you see that fits right on the regular 4-inch box. It does not sit in the 4 11/16 box. You need basically a collared adapter that'll give you the 2 gangs on there, and then you need a regular switch plate like you would have on your wall to cover that. So stay away from those if you can. Also, you're going to need a box with a ground lug. This screw will not be in there, but you want to get the boxes that actually have the little, see the little bump in there? You want the boxes that have that. Show you a box that doesn't have that. There's a box that does not have that. The reason why is because you're going to be mounting this flush up against a concrete wall. You need space for that screw to go through. Now, the ground screws that you have to, years ago, what we used to do is just use self-tappers and zip them right into the box. Can't do that anymore. You have to have a threaded ground screw go into that hole to hook your ground onto. Now, the other thing is your GFI. Which I'm sure all you've seen probably most likely in your bathroom or outside, and basically this measures any voltage leakage to the neutral. So I could take basically a drop light and drop it in a bucket of water on a regular outlet. Nothing will happen. It won't trip the breaker, won't do anything. This, as soon as I drop that in the water, this will pop. Now, you can get them in outlets like this, or you can get an actual breaker that is GFI protected. Obviously, these are a lot cheaper than the breaker. Breaker will run you about 40-45 bucks. So, these can act the same way as a breaker, and they can be ganged together. So in other words, if you look right here, here's where your power comes into. You have this yellow tape over it here, and it says load. This bottom can feed successive regular outlets, and GFI protect these outlets as long as it's off the load here. So you would come off of here and go to this outlet. off of this outlet to the next, and you can chain them together and protect them all off of one GFI. Now if you put too many on there, you can get nuisance trips. Now usually, depending on the maker, you'll have a pamphlet, and usually it'll tell you how many outlets it can feed. This one does not, but they do come with, they always come with, grab a different one here, little stickers that you put on the other ones. Now you can see there's 6 GFI stickers. So I've always just gone by the stickers and not put more than the 6 outlets on the ends of the GFIs. Like I said, some people will argue you can only put 3, you can only put 4. There is actually no code provision that tells you how many you can and can't put on it. There may be in your jurisdiction, but here there definitely is not. So you'll need those, and then however many outlets you're going to use. Now, the way we're going to be doing it, was going to be dropping a piece of EMT down from the edge of the top there with the wire in it down to the box. So what we need is either 1/2 inch or 3/4 EMT. I'm going to use 1/2 inch because that's more than enough to hold one 12 gauge wire. Like I said, you can drop a Romex wire into EMT for protection purposes. You're not supposed to really, you can actually, there's no code provision that says you can't run this in this as an enclosed system, but they treat this as one conductor, but the size of the conductor is actually the width of the ellipse of it. So as for conduit fill, you'll only be able to get one wire in there if you actually go by the code conduit fills. So now you need connectors to your boxes. So there are 2 types. There is the screwed connector, like this, that just sits on the top. The set screw, it's perfectly fine. I don't particularly like these because it looks ugly. It's just a personal preference. I like compression fittings. Now if they're blue, they're watertight. You don't need those ones. You just need the regular ones. And it's a metal ring inside here that just compresses onto the piece of EMT and holds it on that way. Now that's for the box side. On the other side that's going to be open, where you're going to drop the wire down, you're going to want a cable clamp, which just sits on the top here, and it's just like a regular Romex connector. You tighten the screw down. Now you don't technically need those if you have at least 1/4 inch of the jacket showing inside the box. You technically don't need a cable clamp on the top, but it's a good idea and good practice to put them on there. Now you also need regular Romex connectors to go into your panel. Now they make sure you get a Romex connector and not a BX connector. They do make combo Romex and BX connectors. That's usually what the dimple is for. And then you're going to need some way to attach your EMT to the wall. And you have 2 choices. You can go with the regular half single hole clips, just like that, which work fine. The only problem with it is it's really close to the wall. You can see screw there. You have no and it sits flush with the wall. Now your holes do not sit flush to the wall, so what you have to do is you have to bend the end into what's called a kick. That will line up your hole with your box and still allow you to put this cable clamp flush on them. Now there's an easier way to do that. You use these. Now this just unscrews here. And your piece of EMT goes right in the middle of it, and you clamp it down. Now you can see it already holds it off the wall, and it holds it pretty much in line with those holes, so you don't really have to put a kick in it. Depending on your box, some of these will be a little bit off depending on how far out those are. But usually you don't have to really put that much a kick, or not that much if you use these. Plus these are straight in line with your piece of EMT, so you can just put it up, slap a level on it, put 2 lines here, and then just drill and screw. Now we're going to be going into concrete, so we're going to need some sort of anchors. You can drill and use the it looks like a giant rivet, and hammer them in. There's multiple kinds of cement anchors. I prefer the blue screw concrete anchors. These don't require a plastic sleeve. All you do is, depending on what size they are, these are 3/16. It needs a 5/32 3/16, 5/32 inch drill. So you just drill the 5/32 inch hole and zip this sucker right in the hole, and it grabs. And it's really good for holding light things like this. Another thing that a lot of people miss, especially DIYers, in a wall, whenever you penetrate a stud, and there is a chance that a screw from drywall will penetrate and hit your wire, you need protection. And usually it comes in the form of a cable protector clamp. And all this is 2 spikes, as you can see, on either side, and you hammer that sucker in the end of the stud. It has to be a 1/16 of an inch and UL listed. So, well, it has to be either or. Is this actually? Yes. You see the little UL stamp. That's another thing with electrical code. Anything that is UL listed is magically exempt from all electrical code. As long as it has that little stamp, it's accepted as for use in any electrical application. What that means is, especially for people that have been in the HVAC field, you open up units and the wires are tiny as all hell. The wires are way undersized for what the load and everything is, but because it has that UL stamp, it's perfectly fine. Also, you'll find on pieces of equipment, especially like I said in air conditioning refrigeration trade, the boxes and everything that they have, junction boxes inside the units that are holding all the cables, are tiny, but which would absolutely be illegal if you did it anywhere else, but because it has that little UL listing stamp, it's perfectly okay. Let me just take you over to the wall real quick and show you exactly how these go. Okay, these are the cable protectors here. Like I said, you just hammer them right into the stud, and you can see anywhere that I penetrated through the stud, there's one of these on each side, just because there's going to be drywall on either side. And you can see the plastic stud boxes that I have are the largest ones possible. Also, if you're calculating box fill for any reason and you have a non-standard box size, inside here is written with the actual cubic inch volume of the box for wire calculation, if needed. Okay, as far as tools go, a multimeter is a good idea to check and make sure whatever you're working on is dead. Also, you're going to need normal electric tools. Nice pair of Lyman's, which actually I did a review on these guys a couple of videos back. Regular dikes. Some sort of screwdriver. There's my good old Klein 6-in-1, which I love. Carry this all the time. I picked this up today. This is a Milwaukee 6-in-1, which is specifically for electric stuff, which I will show towards the end of the video. I'll do a quick review of that. You're also going to need something to cut the EMT with. I personally prefer the good old handheld bandsaw. Sawzall will work just fine. It just makes a rougher edge, and good old hacksaw will work just fine too. You're also going to need something to strip the Romex cable with. They have purpose-built little plier type strippers that strip just the cable and nothing else is specifically meant for them. They'll run you anywhere between 15 and 20 bucks. Personally, I prefer the good old $2 Romex stripper tool. All it is a little bent piece of metal with a bent blade on it. You can also use a utility knife, but this, all you do is put this in right on the case, squeeze. You use my thumb, sorry about the squeeze, and pull, and it slices the cable right there. And all you do is peel it back. If you need it a little bit longer, you can always just peel, and it'll come right off. And let me get this out here. It has a handy little gauger if you need it, if you can't tell by the color or by looking at it. And that's pretty much all we're going to need. And I'll start getting to wiring it, and I'll show all that process. All I'm going to do first is just going to mount all the boxes first, and then we'll start wiring this up. But while I'm here, I'll do a quick little review of this guy. I picked it up today, 11-in-1 screwdriver. Now I don't particularly like 11-in-1s because, as you can see, this is a regular 5-1, which just has a shaft, and it has 2 bits on the end with 2 ends. One is the smaller one is the larger one, and 5/16. When you get into the 11-1s, they usually have like something that slides in, and then 2 smaller ones, and usually you end up losing the pieces. Now this one here has that setup. Here's your regular number 2 screwdrivers, and there's your flathead, there's your 1/4 inch. You can pull that piece out, flip it around, there's your 2 smaller ones, there's your 5/16. Now it has something, the reason why I bought this is just because it has something that I've never seen, at least in any kind of combo screwdriver, and that is on this side here. Nope, actually, I'm lying. Here's your 5/16. Actually, back on this side, this shaft here is 3/8. Usually you don't see that. I kind of like that, at least for HVAC stuff. It has your 3 common sizes of nut driver: 3/8, 1/4 inch, 5/16. Now, on this side, it has, if you can zoom in on this bit, they call it a ECX bit. You know, if you can see what that looks like. But it's basically, these screws are combo for either a flat blade and a Phillips, and this blade here is meant to fit that screw perfectly. Does that make a difference? Probably not, but and it's got 2 sizes of those. It says number 1 and number 2 on it. I don't know what the difference is, if it's just slightly bigger, but not much of a difference. Now this also has a hole here, and if you have it on the other side, the same hole here. And that's to act just like the pin on one of the Klein screwdrivers. So you take, this is the 12 gauge wire, and you can put it in and bend yourself a hook. Works pretty good. The only thing though is it's really small, and this is, 12 gauge is a larger size. You can get in there. You can't make a hook on the 10 gauge, but you can do that with the Klein ones. Also, it has this little thing here, which is actually a stripper, which I haven't tried yet, and it does up to 12 gauge, which is probably why this hole only does up to 12 gauge. So let me see if we can turn it and score it, and then pull. Yeah, it actually works pretty good. So you can turn it, pull it, strip it. Give yourself a hook. Actually, that was a bad hook. It's not as intuitive as the pins on the Kleins. You kind of got to figure out where you got to place it. You can't obviously go all the way up to the insulation. You got to back it off a little bit to get the hook. It's not bad. I think it's cost me like $8. One thing I do have to say is this handle is really chintzy, kind of compared to the Klein one. It's just as light, but it just, I don't know what it is. It just feels, this feels more like cheapy plasticky than this. I know this is plastic, but this feels like a hell of a lot cheaper plastic than this on the Klein. Plus the rubber handle on the Klein is a lot thicker than kind of the coating on this. So, I'll try it out at work. and see how it goes. Like I said, I got it mostly because of the idea that it has the 3/8 nut driver in it. I kind of like that. But all in all, I'll probably be going back to reaching for the Kleins mostly. So anyway, so let me get to mounting some of those boxes, and we'll start some wiring.